Hey guys, today in this video we will be looking at vertical stretches of functions. So in general, for any function y equals f of x, the graph of y equals a f of x, where a is any real number, results in a vertical stretch. So this function right here is the vertically stretched form of y equals f of x. Alright guys, now let's understand vertical stretches by using visual graphs. So first let's graph this purple function right here. Y equals the absolute value of x. So when x is 0, y is going to be 0. When x is 1, y is going to be 1. When x is 2, y is going to be 2. And similarly, when x is negative 1, y will be 1. When x is negative 2, y will be 2. And if we connect these together, we will get a graph like that. So now this will be our y equals the absolute value of x. Alright guys, now let's vertically stretch this function by a factor of 2. So how we do that is, remember guys, when we vertically stretch a function, we put a number in front of f of x. In this case, the f of x is the absolute value of x. So if we vertically stretch this function by the factor of 2, we will get y equals 2 and the absolute value of x. And if we graph this red function, when x is 1, y will be 2. When x is 2, y will be 4. And its point will also be at the origin. When x is negative 1, y will be 2. And when x is negative 2, y will be 4. So the red function's graph will look something like this. And as you guys can see, all its points have a y value that's twice as big as the points in the purple function. So for example, if we look at this point in the purple function, we can see that it's 2, 2. But its corresponding point, which is this point right here, its point will be 2, 4. So the y value here is twice as much as this value. So that means that this shows us that the red function was vertically stretched by a factor of 2. And in terms of mapping notation, we can write it as x, y, arrow, and then x to y, because our y's are being doubled. And in general, our mapping notation will be this. Alright guys, now let's try to vertically stretch this function by a factor of 1 over 2. So our equation of that function will be y equals 1 over 2, and then the absolute value of x. Now let's plot the points. When x is 0, y will be 0, so its origin will be right here too. When x is 1, y will be half, so it will be here. And when x is 2, y will be 1, so y is going to be here. When x is negative 1, y will be half. And when x is negative 2, y will be 1. So as you can see guys, we drew the blue function, which is a vertically stretched function by a factor of 1 over 2. And as you guys can see, its points are halfway between the x-axis and the purple points right here. And this shows us that the blue function was vertically stretched by a factor of 1/2. And its mapping notation can be written as xy, arrow, and an x half y. Alright guys, so in summary, if we want to vertically stretch this function y equals f of x, we have to put a number in front of the f of x. Now, if we want to maybe vertically stretch it by a factor of 3, then we will write it as 3 of f of x. And here for this function, our mapping notation will be x comma y, arrow, x, and 3y, because when we stretch a function vertically by a factor of 3, our y values get increased by a factor of 3 as well. Thank you guys for watching. Please subscribe and like the video, and we will see you in the next video.